Hello, everyone, and welcome to the July AUVSI Cascade webinar series. This is a really exciting agenda today. What we're going to do is talk about unmanned systems in the United States Navy, and we are honored to have Rear Admiral John A. Okon with us today. Let me tell you a little bit about ourselves. So AUVSI is the Association of Unmanned Vehicle Systems International. We are a group that represents unmanned systems and robotics. It was begun in 1972 and has continued through today. We are the largest unmanned vehicle systems industry body out there. And this is the Cascade chapter of AUVSI. And the Cascade chapter covers Oregon and Washington, very exciting hubs of unmanned vehicle activity. We have a lot of unmanned air vehicle representation in the two states, and we also have a remarkable amount of unmanned underwater vehicles and surface vessels represented in this chapter. And so today we're excited to talk about some unmanned underwater vehicles and more. So the agenda for today is we're starting now with some introductions and some welcome, that sort of thing. We're going to have Admiral on for a while. We will start a Q&A session at about 12:30. And then at 1 o'clock, we will close things up and we will begin a networking session where we can just meet one-on-one with each of you and get to know everyone. So I look forward to seeing you guys in the networking session and talking with you and figuring out who each of you are and what you guys are up to. And with that, I'll hand off to our Executive Director, Lori Brown.
I'm going to introduce Tom Hagan. Tom Hagan is our moderator today. And Tom's got a wonderful background. He is past president of our chapter and current president of his company, Enterprise Initiatives. He founded that to provide consulting, management, and education services to the aerospace community and government agencies in aerospace and unmanned systems. He's a retired Navy carrier aviator, and he previously worked for the Boeing Company for 13 years, where he was the company's unmanned carrier, launched airborne surveillance and strike system business development lead for Phantom Works. So with that, Tom, take it away. Thanks.
Well, thanks, Lori, and good morning, everyone. We're just delighted to be able to facilitate this webinar this afternoon in Mississippi time, where Admiral Okon resides. So let me give you just a little bit of background about the Admiral before he starts, and really I think it's a remarkable background. He grew up in Syracuse, New York, and ultimately graduated from the State University of New York Maritime College at Fort Schuyler in 1991. With a Bachelor of Science in Meteorology and Oceanography. So his path was set fairly early on into this professional command that he holds today. He holds master's degrees in Meteorology and Physical Oceanography from the Naval Postgraduate School in Monterey, California, and in National Security Studies from Naval War College in Newport, Rhode Island. Initially, he was a junior officer and as a surface warfare officer served on USS Ticonderoga, an Aegis-class cruiser, and then later was a meteorologist and oceanographer on the USS Dwight D. Eisenhower, an aircraft carrier. Ashore, he's had positions as an optimal track ship router at the Naval Atlantic Meteorology and Oceanography Center. That's a job where, and the Admiral probably will wince when I say this, but they decide what are the best, most favorable weather paths for ships transiting across the ocean, where oftentimes there's been a paucity of meteorological information. So it's an important thing, particularly when you get into hurricane season and some of the areas that have traditionally agitated sea states, to say the least. He was an aide to the commander at his present command. So I guess that started his legacy there early on. Operations officer and executive assistant to the deputy director for regional operations on the Joint Staff. He was the senior oceanography assignment and placement officer at the Navy Personnel Command and executive assistant to the deputy chief of naval operations and information warfare and director of naval intelligence. He has commanded the Naval Oceanography Anti-Submarine Warfare Center in Yokosuka, Japan, and the Fleet Numerical Meteorology and Oceanography Center in Monterey. Today, he is the commander of the Naval Meteorology and Oceanography Command at Stennis Space Center in Mississippi, and also the oceanographer and navigator of the Navy. When you think about the entirety of the Navy, those are pretty awesome responsibilities to say that you are the oceanographer and the navigator. There are a lot of interesting facets to that. He has, as I mentioned, a command there at the Stennis Space Center in Mississippi, but a number of satellite commands as well under his ownership. We certainly want to welcome you to our AUVSI Cascade chapter webinar, Admiral, and delighted to have you here. Thank you very much for spending time with us today. This is part of the Seattle Fleet Week, virtual Fleet Week this year. So we look forward to learning more about the Navy's use of unmanned systems and specifically how your command is involved in this dynamic technology sector, especially in day-to-day development and employment of unmanned systems. So with that, Admiral, over to you, sir.
Great. Thanks, Tom. Appreciate it. Let me see if I can share my content. Yeah, I really do appreciate this opportunity to be with you today. I really wish I could do it in person in the Pac Northwest. And I've been planning on this for about a year. When the schedule came out, we actually had a ship that's operating off the coast right now. I've been operating there for about 60 days. And then unfortunately, because of COVID, we can't bring her in and give her the tours that we would want like we did in New York a couple years ago. But as Tom said, this is the first time we're doing a virtual Seattle Fleet Week, first time in 70 years. And I had an interview that's gonna air on King 5 on Monday, and they asked me, how do you do a virtual Fleet Week? And I said, the Navy's agile and adaptive. We learn to fight through conditions, and there's nothing more important than getting out and getting connected with our communities to show them what their Navy is doing for them. And that's what I'd like to do for you today. Before I get into the unmanned systems part, I'd like to put in general context what your Navy is, where we're at, and what we're doing on your behalf. And then I'll have about 15 or 20 minutes, and I'm going to walk you through my community and talk about all the different unmanned systems that we've got in play right now. So let me set the stage, take a moment, and I'm going to take you all the way back to 1781 and the founder of our Navy. And it's a quote from George Washington, because I really think it does summarize what your Navy is all about and what we're doing. And it goes like this: as certain as night succeeds the day, that without a decisive naval force, we can do nothing definitive, and with it, everything honorable and glorious. And I think that really does hit to what are we doing? You do have a decisive Navy, and it is honorable and glorious. And I've been doing this 29 years, and I could not imagine doing anything else in this world with my life and with the people that I'm doing it with, because it really is just a great team. Yes, and so honorable and glorious, providing sustained combat operations, incident operations at sea. That's our job. Provide sustained combat, incident operations at sea. We are forward deployed in every corner of the world, and I'm going to walk you through that. Doing your business. And yes, we've been doing it since October 13th, 1775, when the Continental Congress established our Navy. This sort of boils down what your Navy is doing for you, right? Why do we provide combat incident operations at sea? It really is to promote American interests, preserve the peace, and protect the homeland. With 70% of the earth covered by water, 90% of global trade conducted on the maritime commons. Yes, 90% of global trade travels by sea. 26% of U.S. jobs are tied to that global trade. Over a quarter of our economy tied to that trade on the sea, and 26% of manufacturing jobs depend on exports. So you put that all together, and you can see why having open sea lines of communication are so vital to protect not only our interests, but preserve the peace and make sure if we are ever going to fight, and if we have to fight, that your away team has home field advantage forward. Yes, your away team is the United States Navy with 340,000 officers, about 282,000 civilians. We have 300 ships, 63 are underway, forward deployed, doing those kind of things that you need us to do to protect our economy and make sure bad people don't get towards us. Eastern Mediterranean, high north, South China Sea, Straits of Malacca, that's where your Navy is. 4 of 11 of our aircraft carriers, 4 of 11 of our aircraft carriers are currently underway in the Western Pacific, Central Command, and the Mediterranean, keeping those sea lines of communication like the Straits of Hormuz, the Straits of Bab el-Mandeb, which I'll show you in a minute, is a significant choke point for us, and the Straits of Gibraltar. Key areas where that commerce flows through an American presence is absolutely required. And so, yes, there are bad people all around the world that wish to do harm to us. You can see some of these key hotspots. Many of them are probably very familiar with you. China and Russia being global rising peer competitors. But we still have regional conflicts in Libya, Syria and Iraq, Afghanistan. North Korea is still causes problem in East Asia, Sea of Japan. And so that's where your Navy's at. That's where your Navy is. And it's because of the world order is being challenged, and open sea lines of communication are vital to our American economy. And so that's where your Navy is doing their business. And I'm going to talk about a number of areas in the end where there are unmanned systems, making sure that we understand the environment in which our Navy is operating. Okay, so what are we doing around the world for you? Here it is, quick snapshot. We'll start in the upper left with U.S. Fleet Forces Command. That's my boss, Admiral Chris Grady. Admiral Grady owns from pole to pole, from the East Coast to the middle of the Atlantic. Really heavy presence with NATO. We've done a number of NATO exercises in the past few years, and that alliance in the Atlantic is critical. Over in Europe, Naval Forces Europe, Admiral Bob Burke, just relieved Admiral Jamie Fogo. A lot of theater security cooperation, a lot of partner nation building, interoperability, and again, NATO support. Black Sea operations are critical. We all know about the conflicts between Russia and Georgia. We've got some great friends in the Black Sea. And so making sure that body of water and the straits through Turkey remain open are critical. Over in Central Forces Command, we've got 5th Fleet and Admiral Jim Malloy, headquartered in Bahrain, firmly focused on Operation Resolve, counter-piracy operations in the Horn of Africa and the Straits of Bab el-Mandeb. Keeping those sea lines of communication open are absolutely critical for Central Command. Down in Naval Forces Southern Command, counter-narcotics operations remain really, really firm, coming out of the Caribbean and also the Eastern Pacific. And we have a number of ships operating out there looking for semi-submersibles, low-flying aircraft, and ghost-fast boats that are transferring narcotics from South America and Central America to the U.S. Naval Forces Africa has been a rising area for us for a number of years when we stood it up just about a decade ago. Counter-piracy operations in coordination with Naval Central Command, maritime security operations in what I'll call the elbow of Africa near New Guinea and Gabon. A lot of counter-piracy in that area as well as the Horn of Africa, and a lot of trafficking comes out of that area. So we work with our partners, learn to build their maritime security forces, their coastal forces. And then over in U.S. Pacific Fleet, Admiral Phil Davidson, who's the PACOM commander, but then the fleet commander, Admiral Lung Aquilino, they have their hands full with the South China Sea and the Western Pacific. I think everybody has probably read about the China building islands in the South China Sea, the Spratlys and others, and wishing to push their new world order, a more authoritarian one, onto our friends in that area. So heavy presence with the forward deployed naval force in Japan, with the Ronald Reagan and her strike group, constantly operating in Philippine Sea, Western Pacific, South China Sea, and East China Sea. A vital part of everything that I just talked about in the slide is understanding and exploiting the physical battle space that are better than our adversaries. Not a ship gets underway, an aircraft flies, or submarine sails without the support, the direct physical battle space awareness from Naval Meteorology and Oceanography Command. And I'm incredibly proud to lead that organization of 2,500 personnel. I'll talk about a number of ships, 4 deployed around the world, 60 different locations. Of the 2,500, we have about half military, half civilian. The half military are about 900 enlisted sailors and about 350 officer sailors. Okay. So I went through that quick. I can talk about the big broader Navy at the end, but I think what I'd really like to do is focus on unmanned systems, which are absolutely a game changer for the Navy and for naval oceanography. So what you see right here is a snapshot. I'll just sort of let you soak this up, because I'm going to go around and talk about each one of these tiles and how they relate to what we do and what we deliver to the Navy. 1/4% of the overall Navy budget, 1/4% of the overall Navy budget is responsible for the physical battle space from the bottom of the ocean to the stars and from pole to pole. 1/4% does what I'm going to talk about. So let me start with some commands. I have 606 commands: the Naval Oceanographic Office, which is headquartered here at Stennis Space Center, Naval Oceanographic Office, or you'll also hear me refer to it as NAVO. They really are concentrated on the oceanography aspect of the battle space. They operate 6 forward deployed, full spectrum oceanographic survey vessels. It's the Pathfinder class, and if you see those 2 white ships in the upper right and the lower left, that's what they look like. NAVO is comprised of about 800 civilians and about 50 military. Heavy science focus. They collect, analyze, and predict the physical oceanography. They also do magnetics, acoustics. Really world-class organization that's not been repeated anywhere by any country. And they've been down here. That really is sort of the lifeblood of our community when it comes to the ocean. Out in Monterey is the Fleet Numerical Meteorology and Oceanography Center. It's the DoD's premier and only assured numerical weather and ocean prediction command. It's about 180 personnel. And if you heard Tom, you may see me smile when I say FNMOC or Fleet Numerical. As you heard Tom, I commanded that from 2013 to 2017. This is a command of numerical modelers, and you can think National Weather Service like, but we do it in areas where it matters to our Navy and to our interests, in all the areas which I just talked about: Straits of Bab el-Mandeb, Straits of Gibraltar, South China Sea. We have a suite of atmosphere and ocean models that are tuned specifically for our needs and tuned for the areas in which we want to operate. We run global and regional ocean and atmospheric prediction across all 3 classification levels: unclass, classified, and then at the top secret level as well. Our third major, I'll call production command, is U.S. Naval Observatory. And so everybody that has a cell phone or a GPS watch that gets time benefits from the U.S. Naval Observatory and Naval Oceanography, because that time standard that GPS clocks run off of compare themselves to our nation's clocks, which are run at the U.S. Naval Observatory. And not only that, but it's a really unique place in Washington, D.C. It's about 150 personnel. They have astrophysicists. They have engineers. You name it. It is a world-class organization. That is truly the genesis of this community when Matthew Fontaine Maury established it just off the mall, and then later moved it up the hill to the Naval Observatory. They run a suite. I said they run a suite of clocks. They also run a global network of telescopes that look at stars and produce star catalogs. So if you've ever done celestial navigation and used the Nautical Almanac, they're a co-producer of that with the UK United Kingdom Hydrographic Office. They also have a suite of telescopes. They're called very long baseline interferometers that look at the stars to determine the Earth's wobble of on its axis. The Earth doesn't just rotate around its axis naturally. It has a slight wobble, and so we're able to look into deep space to make sure we get that right parameterization of the Earth, exactly where it is, so that when we have precision guided munitions, that we know exactly where they're going to land. Those are called Earth orientation parameters. Let me get more and so those 3 commands are heavy on the civilians. Let me get more into the military side. Our Naval Oceanography Operations Command They run a distributed network. These are really the forward deployed force doing mine warfare, special warfare, and anti-submarine warfare around the world. That headquarters, the Naval Oceanography Operations Command, is headquartered here at Stennis Space Center. But again, very small, tight footprint here. The majority of their folks are forward deployed, co-located with critical C2 decision makers, command and control decision makers, like carrier strike groups and numbered fleet commanders. And then I have two main centers, one in San Diego, one in Norfolk, that predominantly do the same thing. They split the globe in half, and they're called the Fleet Weather Centers. These are the centers that are responsible for writing forecasts to keep our ships safe and out of harm's way. And Tom, I got to tell you, I couldn't have said it any better. You absolutely nailed what the optimum track ship routers do. And as you know, I was one of those. My career in this community started at Naval Atlantic Meteorology and Oceanography Center, which is now the Fleet Weather Center in Norfolk. But these are 24/7 operations that have overwatch of our aircraft, our ships, and our submarines, and are writing them daily forecasts and routing them around severe weather that could potentially damage our nation's investment and hurt our precious resource, which is the center of the universe, which is our people. Okay, so there it is. There's sort of big Navy, Naval Oceanography. Now let me dive down into unmanned systems, and I'll start first. I really have about 5 main commands that use unmanned surface and unmanned underwater vehicles. And I'll start first with the Naval Oceanographic Office. If you look in the top right and the bottom left, you'll see 2 of our TAGS vessels. The one in the top right, that's the USNS Mary Sears, and that's her launching one of a handful of Remus 2,500 meter UUVs. That's a 2,500 meter depth vessel that's got continuous temperature and depth. So it measures salinity, temperature, and pressure. It also has some optics and a side scan sonar on it so we can map the bottom of the ocean. We've got you're going to hear me say Remus a number of times. We have a really good partnership, long-standing partnership with Hydroid up in Falmouth, Massachusetts, that produce and deliver a number of our vehicles. Almost none of our vehicles are built in-house. We leverage industry partners and also academia like Woods Hole and some others to help develop these sensors for us. In the bottom left, you'll see, and so we've got a handful. I gotta, because of classification, I can't give you, on some of these, I can't give you specific numbers that I have. So I'll just, in generality, a handful. There. Down on the bottom left, there's another TAGS operating. It's a Slocum glider. This is a glider that is purchased from Teledyne, also in the Falmouth, Mass area. We have about 150 of these commercial off-the-shelf sensors that can persist in the ocean for anywhere up from 60 to 120 days, depending on how we operate them with their batteries. They also collect. They have a CTD, a continuous temperature and depth sensor on them that collects salinity, temperature, and pressure. And you've heard me say that twice now: salinity, temperature, and pressure. Those are the 3 main parameters that contribute to what the sound velocity profile is in the ocean. And that sound velocity profile is critical for us to understand, and the variability in that, we'll call it SVP, critical to understand how the acoustic signature in the water travels. And so you can understand that SVP is critical to our submarine force, knowing where the enemy may be and where and how their signal may be transmitted through the ocean. Okay, so that's the Naval Oceanographic Office. I think I've covered them completely. Let me go to the Fleet Survey Team, which also works. That's the Naval Oceanographic Office is a captain-led command. The Fleet Survey Team is a O5 or a commander-led command, again, located here at Stennis Space Center. And I'm going to just highlight, going to the top left, that multispectral image that you got right there. That is the first full survey of the USS Arizona since she sunk. We did that 2 years ago during the Rim of the Pacific exercise in Hawaii. She utilized Fleet Survey Team, which is right below. Those are 3 of our superstars getting ready to put in a GPS relay buoy to do a hydrographic survey. they used in the bottom right that little diamond-shaped guy. That's a Teledyne Z-boat. That is a multi-beam. Fully autonomous surface vessel that surveyed the USS Arizona, and the height of that is just about 11. Well, without the direct antennas, those two white things sticking up, just about 11 inches. And so we were able to drive with the national parks, the national park and the Arizona Memorial Foundation permission. We were able to fully survey, drive that Z-boat underneath the platform on the USS Arizona. Fleet survey teams of about 50 people, and they deploy around the world in areas where our big tags, our big oceanographic survey vessels, like the two I talked about in the upper right and lower left, just can't get because they're too big. They'll take a boat of opportunity or a boat such as a 10-meter fixed boat that they own, and they'll go into areas like Chuck, Ponape, Gabon, coastal areas, and survey, map the bottom of the ocean for national defense areas. So if we want to get in there, we want to get access. We also do it in coordination with our partner nations to help them update their nautical charts, which then they can then go back to someone like Lloyd's of London and update their charts, which then lower the insurance rates to come in and out of port. So there's a nation building aspect to this hydrography work. And so they've got about 5 of those Z-boats. Down in the bottom tier, second from the left, you'll see 2 sailors that look like they're on jet skis. Well, yes, they once were a jet ski. Now they're a rapid littoral survey vehicle. These are commercial off-the-shelf jet skis that we modify in-house with a single beam sonar. And we can also launch what they have in their hands there is an IVER, unmanned vehicle that does bottom mapping. It's got a side scan sonar. It's got a continuous temperature and depth, and it can be run remotely on a fixed pattern. They use these in tandem to get into areas just like you're seeing them in, operating in riverine areas or very, very shallow areas. And they can run these, they can run this data real time, offboard it, and process it as they're working. These have been critical in areas like humanitarian disaster relief. Just about 5 or 6 years ago with the big earthquake in Haiti, we took this IVER and these rapid littoral survey vessels and surveyed the port of Haiti leading in to USNS Comfort, going at the pier, going at anchor to deliver relief. 2 years ago, we also did it in the Key West as the USS Iwo Jima pulled into the port of Key West after the major hurricane rolled through there. And so this flyaway capability, we can basically, these rapid littoral survey vessels, we can put on the back of a truck. We can ship these IVERs, and we can be anywhere in the country in just about a day. And if we've got major lift, we can be anywhere in the world in just under a day. And so the fleet survey team is not only using unmanned surface underwater vessels, we're now starting to get into unmanned aerial LiDAR vehicles that can do hydrography up to about 10 meters. We've been working with a number of companies through the Advanced Naval Technology Demonstration, which I'll talk about at the end, which is ANTEX. We've been working with some companies to develop quadcopters that have small LiDAR packages, light detection and ranging, which it's a laser at altitude that can penetrate the surface of the ocean and give us navigation quality data very similar to our FST or our TAGS vessels. Okay, so let me go to the next command. That is the Naval Oceanography Special Warfare Command. They operate because they're the Naval Special Warfare Command. You can see there's no pictures of them, but they use the IVERs that I showed you with the rapid littoral survey vehicles. They use these with special warfare teams to do beach reconnaissance for our special forces. It's a small team that's out in San Diego, co-located with the Naval Special Warfare Command there on Coronado. A small group, and they're forward deployed with the individual SEAL teams. So I have a number of folks, typically 1 or 2 of aerographers mates or oceanographers that are in these SEAL teams doing this kind of work. Naval Oceanography Mine Warfare Center. Down in the bottom tier, second from the left, you'll see a sailor putting a Remus 100, which is also a Mark 18 Mod 1 Remus vehicle, in the water. It's the same one as the second tier from the top all the way on the right. This is a fully autonomous unmanned vehicle that can go down to 100 meters, and its primary mission is to go out and find and locate mine and mine-like objects, and then we offboard it and do detection and comparison to previous surveys to see if anything new has been in there. This is a small team that's located here at Stennis Space Center. It works for the Naval Oceanography Operations Command, which I mentioned earlier. But we also deployed to do Homeland Defense surveys. We have a Homeland Defense survey, which is a survey using these vehicles currently underway in 2 ports off the East Coast to make sure that nobody has gone in and tried to seed the bottom of the ocean with mines, and so we can get our forces out and we understand that our ports are clear. 2 years ago, we did the Puget Sound with a combined survey between NOMWIC, Mine Warfare Center, and Naval Oceanographic Office, and we were up there for a number of weeks doing that port. And so they deploy also forward to Central Command to make sure that we keep significant and strategic sea lines of communication open, which is the Straits of Hormuz and the Straits of Bab el-Mandeb. And these folks are small groups. They deploy in 6 to 10 folks with 2 of these vehicles, 1 boat, and they can go out and operate for about 12 to 16 hours at a time. Okay, I forgot one more, and it's a good segue to my last point, which is the Advanced Naval Technology Demonstration. And so that's in the top tier, second from the middle between the ship and the back of the ship that shows the 9 or 10 gliders there. And this is a technology that we just were made aware of through the Advanced Naval Technology Demonstration, and the Mine Warfare Center teamed up with a company. This is a fully autonomous vehicle that you can see on the front, that the green telescope looking like it's a camera that you can launch at sea from distance. It will settle on the bottom of the ocean, right itself, and then with those tractors, it'll follow the bottom of the ocean, looking around and giving you near real-time pictures from depth. And so this is a capability that we would have never been able to do. It gives us great access at distance, which allows our Navy to stay further offshore and still get the same type of data. What we don't have, the same company has a bigger vehicle that has multiple smaller vehicles. So as you get closer in, the smaller vehicle starts to deploy, and this vehicle can go all the way from depth up to and onto the beach, where you then can recover it. 2 other ones right in the dead center. It's the top is sort of the middle of those top middle of those 4, and that's some of my teammates talking to industry up there in Newport about the Remus 100, trying to collaborate on future capabilities. And then in the bottom right is Antex that we host down here on the Gulf Coast, and that's collaboration with Leidos to bring AI and machine learning with our unmanned systems, so that we can remotely pilot our surface vessels, but we can also make sure that we can operate them in and around shipping areas by putting machine learning and rules of the road, nautical rules of the road, algorithms and technology in it, so that they can onboard make decisions to stay out of the way of larger vessels. And that's a really key aspect for us as we decide to get bigger unmanned systems, unmanned surface vessels, is that we can operate them in dense areas, but also operate them safely with others that are around us. Okay, let me stop there, and I'll open it up for questions. As I do, I'll say America's Navy starts with us. There is nothing we do in the Navy whether it's it's in every domain, whether it's the air, surface, subsurface. Everything starts with understanding the environment and being able to provide more truth than the enemy. Okay, let me stop there, and I'll open it up for questions.
Well, first of all, thank you very much, Admiral, for your remarks. Obviously, you come away from that pitch with just the huge diversity, not only of the United States Navy, which of course I'm well familiar with, but also with the realm of your command and all the touch points around the world that are so critical to our nation's maritime forces and, of course, our national security. So thank you very much for those remarks. Before I get to the first question posed, I guess we have a couple of questions coming in now. I have a couple of my own, of course. I want to feed to you. And the first is really relative to, the membership of AUVSI, which typically, as you saw from the polling at the beginning of this webinar, is oriented around operators or manufacturers or folks providing services ranging from consulting all the way to, power by the hour kinds of contractual unmanned system services. I guess, how would you characterize the increased use of commercial technology in unmanned systems in terms of what it brings to the capabilities of the Navy?
Well, it's critical, and I got to tell you, even just as my time in the community, it's grown exponentially. And in the last 3 years, we've made great strides of stop building our own things, leverage technology, leverage industry partners. And you heard me say a couple times, Hydroid and Teledyne, Astrolite through unmanned LiDAR. It's critical for us for the commercial off the shelf and not home growing it. There are things that are in industry right now, and the Slocum glider is probably the biggest win for us. These are things that the oil and gas industry used to find the right place. How are they going to put their rigs? We just put a different sensor on it and a different battery pack and slightly different communications, because bad people are listening to us. They want to steal our secrets. They love our intellectual capital, and so we have to be a little bit more protective in that. But those Slocum gliders, the Remus 100s, the 2500s, the 6000s, those are largely commercial off the shelf, 85 to 95%. And it's only going to get more. And that's why things like Antex, Trident Spectre, areas where we can go into an unclassed environment, work with industry partners in a two-way conversation. This is not us talking to industry, you will do this. This is about, tell us what you have out there. Here's our problem set. This is what we're trying to do. Tell us what you have out there. And it is really, it's really interesting to watch, because most of these demonstrations are in civilian clothes, right? They're out on the beach, they're in dirty work. And when you go down there to look at them, you cannot tell who's in the military and who is in industry. The partnerships, the really truly belief that we're seeing in the industry wanting us to be better is really, really inspiring. And I'll tell you, it's only going to get more.
So kind of continuing that vein then, for companies aspiring to do business with the Navy who maybe aren't there yet, but have the world's next great idea, are there opportunities other than the formal request for proposal processes that are available, perhaps within a demonstration realm or some other entree to get that going? Yeah,
so I'm a small community, so I have to be a little bit careful on how wide I open the gate, because I could get crushed pretty quick. Right. Trident Spectre and Antex are really the two big ones. We also go in with a number of companies on cooperative research and development agreements. This is an area where there could be a company that's out there that's got a budding technology that we could learn from, but then they could also learn from the Navy. And so I run about 40 CRADAs throughout the country with different industry partners, some big, some really small, very niche. I would ask, if you have something in the ocean, you're doing something on the surface of the ocean, and I would even be broader than that. I would say anything that would help me characterize the physical battle space from the bottom of the ocean to the stars, I'd be very interested in having that conversation.
Great, thanks. Hey, we have a question here a comment by Jake Jacobs, who's on the board of our AUVSI chapter, a frequent sailor on the Coast Guard vessel Eagle. He comments, outstanding technology. You also mentioned Celestial Nav. Does the Navy still use Celestial Nav as a backup?
We do, and it's unfortunately, because how our adversaries are working, it's soon to be not a backup. And so we put celestial navigation back into our curriculums at the Naval Academy. And as a maritime college grad from Fort Schuyler, I still have my own sextant. I still know how to do my own site reduction tables. I know how to still shoot my local area noon, my morning and night stars. And I tell you, denied GPS is a big issue right now. And it's really an issue from our peer competitors, China and Russia. And so we have to be, again, agile and adaptive. GPS is the primary source of navigation, but celestial navigation has never and will never fail if you know how to do it. And I can't talk too specifically, but I will tell you that we are working initiatives to be able to more automate that process in real time.
Admiral, you know, there's a lot of talk these days in the military about distributed operations. You know, being able to take a fleet of gliders, for example, and make them one fleet that works together to make sure that, for example, a survey of a body of water would be more complete and efficiently done than if not working together. Communications clearly are difficult and challenging in the maritime realm, especially under the sea. How do you manage your 150, I think, sea gliders you mentioned? Mm-hmm. Do they work in concert with each other, or are they alone and unafraid out there?
Yeah, that's a great question. It's probably my two biggest problems that I'm trying to solve is communication at depth, so that we don't have to keep coming up to the surface of the ocean and transmitting the data sort of once every 4 or 5 hours, and then the persistency of them. Right now, they don't operate in unison. We have a glider operations center here at Stennis Space Center that can command and control all of those gliders from around the world via satellite communications, but they arguably operate independently. One thing we did do last year with Riptide at Antex was learn a little bit about how you work these in concert as we call it a swarm, right? How can you run them together on track lines, move them in parallel so that you can see the ocean in one area where it's really important for you, and you don't necessarily have to collect in the same area. Where we're at right now, we spread our gliders out pretty good so that they don't do that. But being able to station them, work them in concert, really big issue for us, and we're trying to get after it. But the communication part, keeping that unmanned system at depth, be able to communicate it maybe real time with a platform or with another underwater vehicle that can then take all the data and only once come to the surface. That's really important for us. One, from a force protection issue, right? Every time one of our vehicles comes to the surface, there's a chance that a bad guy may pick it up. In open source a couple of years ago, the Chinese picked up one of our Slocum sea gliders. Then they quickly put it back in the water.
They're curious about everything we do, which is a tribute to both the military and our commercial entities that produce those things.
Yeah, and I apologize for having to be a little high level on some of these. 2 years ago, I made a statement at a Sea Air Space, which is a large gathering in DC, and on a panel about the Arctic, I said, we run a fleet of about 100 to 150 gliders, and I need a fleet of 1,000 gliders. Just 4 months later, an adversary came out, a state-sponsored Oceanographic Institute came out and said, we're on the path for 1,000 gliders, almost verbatim what I said. So I have to be a little cautious, and I appreciate everybody sort of understanding that for me.
Yes, sir. Understand. With all these vehicles entering into service with the Navy, there's a certain complexity to them, not only in the environment that you operate them in, but in the machines themselves. The advent of things like artificial intelligence is a further complicator. How do the sailors get their training? Obviously you partner with technical representatives from the companies that build them, understand that. What's the training for these sailors that need to help manage these out in the fleet?
So there's really three aspects of that. One, there is some training directly from the vendor, mostly on the really high-end, highly technical vehicles. We also have homegrown training, right? How do you just put them in the water? How do you run them? How do you post-process the data? And then we have partnered with the University of Southern Mississippi just a couple years ago for an Unmanned Systems operator course. It's just a few week-long course. Gives them an understanding a little bit. It's sort of in between the vendor training and what we can do in-house with sort of on-the-job training. They get a little bit better understanding of the electronics, if there's troubleshooting they have to do in the field, how to operate them, some of the key aspects that you can see when the vehicle is getting into trouble. And so there's a sort of happy medium. High end, clearly the subject matter experts from the folks that build them, and then sort of in my command, the folks that run them all the time, the tactics, techniques, and procedures, and then sort of that middle level certification education. So really three-pronged approach. And it's not just for our sailors. Our civilians operate these also for mine warfare and hydrography. And so if you come to my community, you'll see civilians and military operating as one. It's really inspiring to see the 1,200 civilians that I have and the passion that they have for what they do and their part on the national security team. Great,
thanks. Another question. Some of the best unmanned technologies are not American made. For example, DJI has 70% of the world's market in small commercial drones. What's the Navy's position on using devices manufactured by companies outside the United States?
So it all depends. We have some good partnerships with nations that are our friends. One of the premier builders of unmanned systems is in Norway, and they make world-class unmanned systems. And the biggest issue for us is the foundry, right? Where are each of the pieces and parts of the electronics made? These systems are no different than your home computer. They can be easily hacked if you don't know what was put into that. So we're open to working with partners around the world, but we have to understand the full foundry of that vehicle and where it was manufactured. It doesn't have to be ours. And you can just see recently the U.S. Navy has awarded the fast frigate hull to an Italian design.
Right.
And so we'll work with our partner nations on that.
So
I didn't say the name, but let me tell you, Kongsberg in Norway, world-class, strong partners. Kongsberg bought Hydroid a number of years ago. Hydroid is a subsidiary of Kongsberg, but it's a wholly owned independent company that was unfortunately recently bought out, or fortunately recently bought out by Huntington Ingalls.
Right. In fact, Kongsberg has been a exhibitor at our chapter symposiums up here in the Northwest. So,
and so I'll give you a great example. And I glossed over this, and I shouldn't have. All of our shallow, medium, and deep multi-beam systems on board our TAGS vessels are Kongsberg.
Wow. So one of the things that we deal with in our chapter is how do we plant the seed corn, get young people interested in the more technical aspects of education and STEM in general. How do we groom those? Do you have procedures or practices or approaches that you use to try and plant the seed that there's an exciting world of unmanned systems out there that do a variety of missions, in your case, meteorological and oceanography related. How do you approach that?
It's Tom. I got to send you some money. You're teeing some ones up for me that we did not talk about. And so this is exactly why I'm at Fleet Week and Navy Week Seattle. Typically on these Fleet Weeks, I will roll in with anywhere from 15 to 20 of my superstars from around the command, around the community. We're going to do it this week also, but we're going to do it virtually. We're going to do science fairs in both unmanned technology. We're going to do science fairs both at Naval Oceanographic Office and at Fleet Numerical with kids at camp in the Pac Northwest. We're going to bring it remotely. Typically, we'll bring them in. Kids will come in. They'll be able to touch it. You'll be able to see how we do low pressure system development. It's really fun. We make it interactive for the kids. They can touch it. They can play with it. This is going to be a little bit different for us, but I don't think there's a bad time to ever talk to kids about science, technology, engineering, and math, and the world that's out there. You read my bio. I'll be completely honest. I went to school to be a broadcast meteorologist. That's why I went. I had a 9th grade earth science teacher that just made me infatuated with the weather, how it worked, the complexity. I was a kid, you can probably imagine, that liked to take things apart, put them back together, but never really put all the parts back together, and then Dad had to come help me. I was always inquisitive. And I think the kids nowadays, if you just show them that there are things out there that they can apply their brain to, be creative. Science, technology, engineering, math does not have to be rigid. It can be, and in my community, it's absolutely not. The basic physical laws, yes, but how we apply them, the critical thinking skills, the creativity that you have in analyzing and predicting the physical battle space is it's a blank sheet for the kids nowadays. And I would hope you'll go to the outreach.navy.mil website every day. I think, let me ask Mate, I think we've got at least 2 or 3 events starting next week that are on the NAVCO website. But we're out and about in schools. All of my 06 commands and my 05 commands, I charge them with, hey, find that elementary school, get a partnership with them, do mentoring, do tutoring, get in there. And it doesn't, not everything in the Navy is about bombs and bullets, right? There's a number of communities in the Navy. Civil Engineering Corps is one of them. I know they're going to be out there. My command's one of them, that you can really use your brain and your critical thinking skills and high-end education for the nation's defense. It's not all about being an engine man or being a bosun mate or being a quartermaster. There's a really highly scientific field out there.
Right. Thanks, Admiral. That was a sweet spot. I know as an Air Wing commander, I used to take my flight gear into elementary schools all over the country and dress little kids that maybe weighed 40 pounds with 50 pounds of gear until they toppled. And it was always a good time, made for great interaction. And
I had the opportunity to go to my hometown about 2 years ago, and I went to my niece's 3rd grade class, and all they wanted to talk about, because they heard I was an oceanographer, all they wanted to talk about was dolphins. Truth be told, I don't do anything with. We do things with dolphins in our Navy for mine warfare, but my community, I don't track dolphins. I'm not a biologist. But yeah, it's great. It's a great community, and you probably see over my shoulder, we've got a few things right here. That's a Slocum glider being deployed off the A-frame of one of my TAGS vessels, and then you'll probably see it. I'll slide to the left a little. You can probably see that. I think we're going to do a recovery here in a little bit. Oh, it's the other side. Yeah, the recovery's over there. So I talked a lot about unmanned systems, but there's a whole other aspect of, well, I'll call it unmanned systems, but they're not unmanned underwater vehicles. And I run a global network of profiling floats. These are floats that go up and down in the vertical, and the water column. They can last many, many years. They do the same thing as the Slocum glider, which collect salinity, temperature, and pressure. But because of the persistency, they don't take as many samples, right? It's usually one every 10 days or so. If you've heard of the Argo network, we contribute to the Argo network around the world. We also deploy drifters, not only for sea surface temperature, but we also deploy Davis drifters that collect atmospheric pressure. We were the first first organization in the world to deploy 105, first one to deploy more than 100, but we deployed 105 Slocum gliders around the world, and we command and control them from one location right here at Stennis. First time ever done. In 21, we're going to deploy 150. We've got to get better at learning to manage manage the data, but control a larger fleet. If we're going to get to a swarming, hundreds and hundreds, you don't go from operating 50 to operating 500. So we're going to make incremental steps out there. And so if there's anybody in the chapter that can talk about AI or machine learning, being able to get the human on the loop instead of the human in the loop, those are things, conversations that I would love to have.
Great, thanks. So what's the next big thing? What technologies do you anticipate coming down the pike that will maybe not necessarily be a game changer, but certainly add to the capabilities that you employ today?
Well, good question. I think if we don't get the next technology jump in high performance computing, chips are getting so small, you're really not able to get much. Moore's law is running out. And to do what we can collect a lot of data, but if we don't have the models to collect it, assimilate it, and then give a predictive output, that's going to be difficult for us to stay ahead. And so the chip technology for high performance computing, I think we're watching very closely. We know we've got the best engineers and designers in the world, and I know they're working on it, and we know they're going to deliver it. So with that, we've already started developing the next generation of numerical models, both in the ocean and the atmosphere. With that new chip technology, you're going to get a new model technology also. Right now, we run global hydrostatic models around the world. And then we run a subset of that with those boundary conditions. We run non-hydrostatic meshed regional models. So in series, but not in parallel. And so we're working with the Naval Research Lab in Monterey and the Naval Postgraduate School on this new model called Neptune, which is a non-hydrostatic unified model of the atmosphere. This is a model that will take us from where we're at right now, using the same compute power to predict the atmosphere in the North Atlantic as in the South Atlantic. And to be honest, I really, as a naval perspective, I don't care what the conditions are in the South Atlantic. It's not where my Navy's operating. But the way we run our model, I have to use the same compute power for both. This NUMA model is going to allow us to temporally and spatially vary the grid spacing, both in the horizontal and the vertical in time step. And so that's going to allow us to take a very fine resolution look in areas where our Navy's operating, South China Sea, and drive that vertical and horizontal resolution down while spacing out that same resolution in places like the South Atlantic. It's going to allow us to use our compute power more efficiently and start to leverage our data sampling more efficiently. If I take in a 5 kilometer by 5 kilometer grid, if I have 2 sensors in that grid, only one sensor is going to count towards the environment. If I can cut that in half or in tenths, right now I can see the ocean a little bit more or the atmosphere, get more data into the areas where it helps us. So chip technology and model technology, I think, are the key ones that we're watching closely.
Oh, great, Admiral. Let's see, Lori, do I have time for one more question, or is our time up here?
And I'll stay as long as you guys want me to. I'm happy.
I'll tell you what, I'll just take the commander's prerogative, if I may, Lori. And
I do know that there was, I have a couple slides here for the webinars coming up from the Chamber, Washington Chamber. I would like to pull those up.
That'd be great. And as you do, Lori, if I could shamelessly plug these.
Please.
This is exactly what Tom was talking about. Having your Navy wants to have discussions with small businesses, and so I encourage you next Tuesday and next Thursday to have those conversations regarding doing business with the Don as a small business. I could, from my time at Fleet Numerical and not only at Antex, I could go on and on about finding that up and coming small business has the passion for what they're doing and has the drive to want to work and develop this technology with folks and get it in our hands. It's been really inspiring. So both next Thursday with Miss Bianca Henderson and then next Tuesday with Mr. Dan DeConzo, I'd encourage you to, if you got time, to pop in and hear what they have to say. They'll help you navigate the discussion Tom and I were having about how to do business with the Navy.
Right. Thanks, Admiral. And certainly I can commend those. I used them when I was in industry as well. They simplify a lot of things by giving you a better baseline of knowledge for the entry points and the various touch points within the Navy acquisition area. So I certainly commend those. Admiral,
It is not big and scary like most folks think, although the DoD, the DoD 5000 is our main acquisition document. Secretary Gertz is really been pushing hard to get rapid technology transition from small and middle business up into the hands of our sailors. The big acquisition providers for the Navy are great. They've been longtime fans and longtime supporters of us, but these small and middle-sized businesses, they've got a seat at the table, I'll tell you. It's specifically with my community.
let's see, we have a couple of questions related to unmanned aerial vehicles. Are you getting more into those? I mean, you mentioned your small ones that have some limited capacity with LiDAR to penetrate the surface of the ocean or some hydrographic capability. Are there others? For example, are you replacing any of your weather balloons with unmanned aircraft systems, or?
Because of some of the issues on our ships with our Raywinson program, which is weather balloons, they go up, they have a small sensor. Usually it was through Vaisala. We walked away from that program a number of years ago. We are working with both industry and academia to develop a fully remote quadcopter version of that, which you put on the deck of a ship, you launch it, it goes up. And typically, we don't have to go for what we need for electromagnetic, electro-optical propagation. We don't need to go up to the top of the atmosphere like the weather balloon said. We really need to go up to sort of the boundary layer, 5,000, 10,000 feet. And also what we need to do is we need to go all the way down to the surface of the ocean where our submarines periscope and communications lie. And so we don't really have a good sense of that right now, but we are working on that type of technology and get it into the hands of our large platforms like our aircraft carriers and our large deck amphibious ships, where we do a lot of aviation support.
Okay, terrific, Admiral. I think we're going to wrap this up from our discussion perspective and flex to the next segment, which is networking. If you'd like to stay around, you're more than welcome. Realize you have a lot of things going on in your business there, but we'd certainly welcome you to stay. Thank you once again for sharing your time with us. And obviously, this is an exciting application of unmanned systems across a variety of mediums, and one which I think there's great promise because of breakthroughs with larger technologies in the submarine world that have now been miniaturized and keep compressing in size to where we can make them more ubiquitous, more welcome in both the commercial oceanography world as well as the military capabilities. So thank you very much. It's been a delight to have you.
I appreciate it, Tom. And I will send you early next week all the information about how the members of the chapter there can get involved with us at Antex. And I'll send them exactly where to send the proposals, the timelines. I'll lay that all out for you.
Oh, terrific. Thank you, sir. Lori, over to you.
Thank you. So right before we get into the networking, I did want to mention that our next webinar is August 28th, and it's all about networking. So it will be an hour of networking and more details to follow, but hopefully you can put that on your calendar, and we look forward to seeing you. And we do want to thank our annual sponsors as well. The platinum sponsor, Hood Technology, Northwest UAV. Our gold sponsors, Aerospace Magazine, EPB&B Insurance, Perkins Coie, Near Space Corporation, and Tillamook Test Range. So without their support, we wouldn't be able to provide our STEM grants and continue our operations. So we appreciate that. So thanks again. And with that, Jeff, you want to kick off the networking?
All right. Yeah. So thank you, Admiral, and thank you, Tom and Lori. You guys did a great job representing the chapter, and as a former submariner, I can appreciate a lot of the importance of the meteorological information that's gotten out of those types of systems. So if you guys, if there are people out there that have questions or want to join the networking, I think the logistics are, correct me if I'm wrong, Lori, but raise your hand and we will get started. But for those of you that are watching this pre-recorded, really appreciate it. We're going to turn off the recording here now.